All right, so we're going to take a look at problem 2 from the Math Counts Competition 2017 Team Round Chapter Competition. So, pretty cool geometry problem, and I have a couple more geometry problems from this very same competition coming in a moment. So, make sure you check those out too. All right, so number 2, first things first, let's read the problem. So the problem says, a circle is inscribed in a right isosceles triangle whose legs are 8 inches long. Okay, so let's try to figure out what that really means. So we have an isosceles right triangle. So clearly we know that this length right here, I'll use a color that's a little easier to see. So we know that this length right here, that is a right angle. And we also know that this is going to bring into play what we know about isosceles right triangles. And so just to remind you, we have an isosceles right triangle. These sides are the same. These angles are both 45 degrees. And if this length is x, well, the other leg has to be x, and the hypotenuse, this long side, is going to be x times the square root of 2. So that means that this whole distance from here to here is going to be 8, 4 times, times the square root of 2. Now, it also means that when we're trying to find the area of the shaded region, let's read the rest of the question. The rest of the question, inscribed. That means that the circle meets at exactly 3 points on the triangle. So that means we have 3 points that are tangent. That also means that if I were to draw a center and 2 radii, we know that this also meets at a right angle. And I can draw this one too, so that's a right angle. So that's what that whole sentence tells us, which is actually really, really helpful. And so then it says, how many square inches are in the area of the shaded portion? Express your answer as a decimal rounded to the nearest hundredth. Now, the thing that I find the most challenging in this is to remember them rounding to the nearest hundredth, because that means I really cannot round until the very end. All those nasty decimals that we get along the way, we got to keep those until the end, or else we're liable to make a mistake, at least due to rounding. So here's what I know. I know, because this is an isosceles right triangle, that we have our base, we have our height. So the area of the triangle is going to be equal to 1/2 times base times height. And so 1/2 of 8 times 8, well, that's 32. 64 divided by 2 is 32. So we know the area of the whole triangle is 32. But we have this circle, right? And we have this circle, and we're taking the area of the circle out of the area of the triangle. So therefore, I need to find the area of the circle, and then once I find that area, I'm going to subtract that area from the 32. So here we go. The first thing I want to do really is I want to drop an altitude from this triangle. And as luck would have it, this is still a 45-degree angle. This is a right angle because it is tangent. That point is tangent to the circle is tangent to the triangle. So I know I have another isosceles right triangle, which means that this length from here to here, that's going to be half the distance here, so we get 4 times the square root of 2. How's it going, Tyler? Have a good day.
Yeah, you see, so I was getting my basketball shoes.
Oh yeah, don't worry about it. All right, so then, if I look at this shape right here, well, that's a kite, right? So I know that this side length and this side length are equal. I know that this is a radius. I know that this is radius as well. And then if I'm looking at this side right here, I know that is going to be equal to this side right here because I have a square. I have a right angle, a right angle, a right angle. They're all right angles, right? So that's a square. And so if this is a length of the radius, then from here to here, that's also the length of the radius. Well, if the whole side length here is 8, that means that this segment right here is going to be 8 minus the radius. So this side length is 8 minus the radius. But wait a second, it's also 2 times the square root of, 4 times the square root of 2. So you know what that means? That means that 4 root 2 has to equal 8 minus the radius. I can now find the radius. How awesome is that? All right, so I'm going to pull up my calculator. And so I need to turn this into decimals. And remember, the answer needs to be rounded in the nearest hundredth. I really, really have to keep all the decimals I possibly can. So I want at least 4, maybe 5 decimals carrying through. So here we go. I need to turn 4 root 2 into a decimal, so I'm going to do 2, find the square root. I'm going to multiply that by 4, and so here is the length of that side, or half the hypotenuse, the big triangle. And then I'm going to subtract 8 from it because, well, I'm trying to solve for r. And so that gives me negative r is equal to this decimal. So negative r right here is equal to the decimal, so multiply by negative 1. So I have my radius. So this is my radius right here. Whoa, that's really big. So there's my radius. So I know the area of a circle is equal to pi r squared. So I need to square the radius, multiply it by pi. Now, it's tempting to say 3.14, but remember, nearest hundredth, we need to keep more decimal places. So the best thing is if you have a pi key on your calculator. I don't have that, so I need more decimal places. So I know pi is 3.14159. That should be sufficient. I hit enter. Okay, so now I need to subtract this value right here from 32. So what am I going to do? Turn that negative. I'm going to add 32. And so my answer is 14.75. And there you have it. All right, I hope that was helpful. And feel free to check out the other two that I'm about to post.